Hello everyone, in this video I'm gonna teach about addition and subtraction method, solving the system of linear equations or simultaneous linear equation with addition subtraction method. Look at this example. X plus y is equal 3, x minus y is equal 5 or 2. Okay, now we want to solve this system of linear equation. As I told you in the previous videos, we have three methods: graphing, substitution, and addition subtraction. I explained the substitution method in previous video. For addition subtraction I'm explaining right now. Now if I add both sides of this video, because this in the top equation left side is equal right side, in the bottom equation again left side is equal right side. If I add the left side to each other and right side to each other, again the third equation is going to be right. So if I add the right side of this one, I'm adding these two equations. X plus x give us 2x, and positive y, negative y, these two cancel each other. It's going to be 0. Is equal 3 plus 2 is 5. Okay, can you see by adding the two sides, one of the variable is eliminated. That's why for addition subtraction method in some books they call it elimination method as well. Now 2x is equal 5. If I divide both sides by 2, x gonna be 5 over 2. Okay, now this is one answer. In either of these equations, if instead of x I substitute 5 over 2, and because 5 over 2 I can, if I change it to decimal, I will find exactly the same value, the exact value. I can write x is equal 2.5. Now if instead of x I substitute 2.5 for any of this equation, this one or this one, okay, I can figure out y. It doesn't matter in which equation, I pick the equation which is easier. I'm going to pick the equation, top equation, which is x plus y is equal 3. Instead of in this equation, I substitute x equal 2.5. Instead of x, I substitute 2.5. So it's going to be 2.5 plus y is equal 3. If I move this 2.5 to other side, y going to be 3 minus 2.5, or y gonna be 0.5. So x is 2.5, y is 0.5. This is the answer of this simultaneous linear equation. How we can check if instead of x I substitute 2.5, instead of y I substitute 0.5, then 2.5 plus 0.5 is 3. 2.5 minus 0.5 is 2. Can you see they work in both of them? And in this way we can check that if our calculation is right. Let's do another example. X minus y is equal 5. X plus 2y is equal 7. I'm just making up the equations. Now for this one, as you see, if we add them or subtract them, none of the variable gonna be eliminated. What can we do? We can change one of the equation or sometimes both of them in a way that when we are adding them or subtracting them, one of the variable be eliminated. As an example, if the top equation I multiply both sides by this negative sign, both sides of this equation. Remember, we have to multiply both sides of the equation by a negative sign, or multiply by a number, or divide by a number. We cannot do only one side. We have to do both sides. If I multiply both sides of this equation by negative y by a negative sign or negative 1. Then this one gonna be changed to negative x and this one is positive x, then these two gonna cancel each other, okay? Or if I multiply this one by negative, by only a 2, not negative. If I multiply this one by 2, if I multiply this one by 2, then this one 2 times negative y is going to be 2 negative 2y. Then negative 2y and positive 2y going to cancel each other. Again, one of the variable is eliminated. It doesn't matter which one, the negative 1 or 2, it doesn't matter, we eliminate the variable, the x variable or y variable. It doesn't matter, always at the end we end up to the same answer. Okay, let's solve by 2 and then I'm going to solve the same example by negative 1 to see it doesn't matter, we end up to the same answer. If I multiply both sides of a top equation, and then it's going to be 2x minus 2y is equal 10. 2 times 1x is 2x, 2 times negative 1y is negative 2y, and 2 times 5 is 10. Remember, you have to multiply everything, not only one side, or not skip any of the terms. Okay, now what is the bottom one? Is x plus 2y is equal 7. Now if I add both sides of this equation, 2x plus x is going to be 3x. Negative 2y and positive 2y cancel each other, and 10 plus 7 is going to be 17. Let me just change this one to 5 because I don't want to end up to the fraction or decimal number. I want to make it easier. Let's change this one to 5. Okay, then this one going to be 5 and this one going to be 50. Okay, I just want to avoid involved with a fraction or decimal. Okay, now 3x is equal 15. If I divide both sides by 3, then x gonna be 5. Okay, x is 5 for this answer of this simultaneous linear equation. In either of this one, it doesn't matter in which one, instead of x, substitute 5 and then find y. As an example, in this one, if I, in the bottom equation, if instead of x I substitute 5, that's going to be 5 plus 2y is equal 5. Move the 5 to the other side. Then going to 2y plus is equal to 5 minus 5, or 2y is equal 0. Divide both sides by coefficient of 2. Then y gonna be 0 divided by any number is 0. Remember, 0 divided by any number is 0. So what is the answer? 5 and 0. X 5, y 0. How we can check? If instead of x I substitute 5, instead of y substitute 0. X 5 minus 0 is 5. And again 5 instead of y 0, then 2 times 0 again is 0, then x gonna x 5 plus 0 again is 5. Can you see it's work in both equations? Now what answer we end up by adding, by multiplying the top equation by 2, 5 and 0. I'm writing this answer here, 5 and 0. Now I want to do the other method method of multiplying the top equation by negative 1 to show you that we are going to end up to the same answer. Let me release this one. Okay, I'm going to substitute this one by a negative sign or negative 1. Okay, then what's going to be negative times positive x is going to be negative x. Negative times negative is positive y is equal negative 5. Okay, and what about the bottom? X plus 2y is equal 5. Okay, the bottom equation remains the same. Now if we add these two equations, okay, x and minus x plus x, these two cancel each other. Y plus 2y is going to be 3y is equal negative 5, positive 5 is going to be 0. If we divide both sides by 3, then y going to be 0. Now, in either of this equation, instead of y, substitute 0. It doesn't matter which one. We will always end up to the same answer. If in the top equation, y is 0, right? So, x, I write here, x minus 0 is going to be 5. X minus 0 is x, going to be 5. Okay? What is the answer? 5 and 0. Can you see we end up to the previous one? So it doesn't matter how we eliminate one of the variables. The only purpose is eliminating one of the variable and solve the equation to find the other variable, substitute the value of the second variable that we found it in one of the equation and find the value of other variable. This is the substitution method. Let's do another example. I'm just showing any type of any situation that we should face in eliminating one of the variables. Let's say for this one, 3x minus 4k is equal 12 and 4x plus 5k is equal negative 7. Okay. Can you see in this one, it seems that we cannot eliminate none of the variables, but we can do it. Again, we have different methods. Look at this one. If this negative and this one is positive. So if I want to eliminate this k, the sign is working, okay? But the number is not working. What we should do? If I multiply the top equation by coefficient of k, which is 5, and multiply the bottom equation with the coefficient of top one, which is 4. Okay, then what can I be? 5 times negative 4 is 20, or negative 20, 4 times 5 is positive 20, then these two cancel each other. Okay, or if I multiply the top one by 4, the bottom one by negative 3, then these x's cancel each other. Okay, I just pick up k, but you can pick up any of them, it doesn't matter which one. So if we continue, then gonna be 5 times 3 is 15x. 5 times negative 4 is negative 20k is equal 5 times 12 is 60. What about the bottom one? 4 times 4x is 16x and 4 times 5 is plus 20k is equal 4 times negative 7 is going to be negative 28. Now, if we add these two, then negative 20, positive 20 cancel each other. If we add these two, 15x plus 16x is going to be 31x. Negative 20k plus 20k cancel each other, and 16 minus 28, because we are adding 16 plus negative 28, which is going to be 16 minus 28 is 32. Okay, if I didn't make mistakes, 5 times 3 is 15, 20, 60, 16, 20, and 28. So 31x is equal 32. If we divide both sides by 31, then x is going to be 32 over 31. This is x. Okay, now instead of x, in either of these equations, substitute 32 over 31 and find k. As an example, if in top equation, instead of x, this 3 is here, instead of x, substitute 32 over 31, right? Then minus 4k is equal to 12. Can you see in this equation, we have only k as unknown. If I move this 4k to the other side and this 12 to this one and simplify this 3 times 32, it's going to be 96 over 31 minus 12 is equal to 4k. Okay, I don't know, because the number are just very random numbers, we end up to this fraction. If let me see if I can change this 31 to 96 divided by 31. Oh, it's not the exact number, so we have to keep in this format. Okay, if I don't make mistakes, 3x plus 4k, 4x plus k, 12 and 7, 5, 15, 20, 60, 16, 20 and 28, 32, 31. No, it's not is the same. So for just substituting this one, we can say if we have here 31 is the denominator is going to be 96 minus 31 times 12. Get 31. If I give a 1 denominator to this one, then 31 divided by 1 is 31, and 31 times 12 is going to be 31 times 12 is going to be 372. 372 is going to be 4k. Okay, writing here. Then if I give a simplify this one, is equal 4k. If I multiple, because I'm looking for k, I'm not looking for 4k. If I multiple both sides of this one by 1 over 4, okay, if I or divide both sides by 4 or multiple both sides by 1 over 4, 1 over 4, and multiple this side by 1 over 4, then this 4 and this 4 cancel each other. I have k here, and what about this one? K gonna be equal to negative 276 divided by these two can cancel each other, but anyway, this one is 1, this one is 69, so k gonna be negative 69 over 31, negative 69 over 31. As you see, the main point of this one is if none of the variables are eliminating in the first step, how we can change the equation in a way that we eliminate one of the variables. Okay, so this is for addition and subtraction method. The only method that is I need to teach is graphing method. I'm going to teach it in separate video. Bye for now.